Hello, my name is Mei Chengye from National Taiwan Normal University. I will present you our recent work. It's a embedding-based approach to address the generalized zero-shot recognition problem. So the goal of zero-shot learning is to recognize objects whose instances may not have been seen during training. So in this example, we have a couple of scene classes. And during testing, an elephant image comes in, which apparently does not appear in the training sets. In generalized zero-shot learning, a test image may come from either a seen class or an unseen class. So this is more challenging than conventional zero-shot learning. So to associate seen and unseen classes, people usually assume the availability of a semantic space where each class is represented by a vector representation. They can obtain from human annotations, human annotative attributes, or from word embeddings. To process the visual data, what image may come in a neural network model to compute the visual feature. So most embedding-based approaches to address the zero-shot learning problem is try to learn the correspondence between the visual and the semantic space. So one example is we map images from the visual space to the semantic space. And that common space, the inference could be performed. Another perspective of these embedding-based approaches is actually we are learning the correspondence between a image classifier, that's the visual representation, right? And its corresponding semantic representation. So what are the drawbacks? First, the assumption of using a single image classifier for each class is not reasonable because there could be more than one approach to separate classes in both visual and semantic space. Second, the scale of training data for learning the correspondence is such constrained to be the number of class labels. Finally, that could introduce the happiness problem because each class is represented by only one single class prototype in the semantic space. So what we propose is a new learning paradigm that we propose to learn the correspondence between an image and its corresponding label classifier. So for example, this image, this training image, we learn the corresponding label classifier to separate lion and other semantic factors in the semantic space. Another sample in the same class could have a different label classifier, and the form of label classifier could be either linear or nonlinear. So some highlights of this approach. We propose to learn a semantic classifier from one image. So it has this adaptive nature because label classification is conducted by an image conditioned semantic classifier. The weights are generated on the fly. It has very few hyperparameters. It could be trained end to end. It's very compact but powerful. It also alleviates the happiness problem. We evaluated the proposed approach on 4 benchmark data sets. And the result shows that this approach outperformed most embedding-based zero-shot learning approach on most of the benchmark data sets. For more information, please come visit us at Gateway Town during the poster section. Thank you for your listening.